Happy Friday, everyone. Sorry that I'm not here today. I've needed a break with my shoulder, so we're going to go ahead and go through the notes for 3.2, Day 2. Good thing is you guys already know how to use everything on your calculator, so we're just going to learn today about a special type of standard deviation when it's considered bell-shaped. Okay. So just to recap from yesterday, standard deviation is thought of as the mean of the mean. Okay, or in other words, remember it's like the average distance that each data value is from the mean. Okay. The most concise way of summarizing data when the data is bell-shaped. So remember we talked about that you guys are going to be asked to find different ways to explain data. When the data is bell-shaped, then standard deviation is considered the best way to describe it. The distribution would be roughly symmetric. Okay, remember that means roughly normal. And we actually talked about this point yesterday. The larger their standard deviation, the more disperse or spread out the data is. Okay. All right, so in our calculators, just to review, if we look at this screen here, okay, remember that this is the standard deviation. Okay. It's represented by that on our calculator. But to get the variance, we have to square that number. So our calculator isn't going to give us a variance unless we go through the list like we did yesterday. But if we're working with the one-var stats screen, then you just have to square the standard deviation. All right, so what we're going to do now, if you guys can get out your calculators. Okay. And go ahead and enter all this data into list 1. And if you could pause the video so that way students can go ahead and enter that, and when they're ready, go ahead and hit play. Alright, so here's what you guys should have gotten for the mean, median, mode, range, and standard deviation. I left variance alone for right now so that we could talk about, once again, how to find that. So this is the variance. Okay, and this is the standard deviation. So remember, to find variance, after we get standard deviation in our calculator, we have to square that. So you take 2.45 and square that into your calculators, and you should get the variance to be 6.002 or something approximately around there, depending on when you guys round it. Okay. All right, the next part then is to describe the distribution. Is the data skewed left, skewed right, or bell-shaped? Remember, we talked about this actually 2 days ago. In order to decide that, looking at the data, you need to compare the mean and the median. So we look at the mean and the median. In our situation, the mean is less than the median. Okay. The mean always goes in the direction of the tail. So in this case, our example is skewed left. Okay. And then based on your part B, is a standard deviation a good measure of dispersion? The answer is no, because remember that standard deviation is for only when we have bell-shaped data, which is when the mean is approximately equal to the median. All right, for the next example, you guys go ahead and plug all this into your calculator. I'm just going to tell you the mean and the median so we can answer the rest of the questions. So the mean is 32.1 and the median is 32.5. Okay. So part B is asking us to describe the distribution, skewed left, skewed right, or bell-shaped, and we want to compare the mean and the median. The mean is approximately equal to the median. They're only 0.4 away. Okay. We don't really have like a set number, so if the mean and the median are 0.5 away from each other, then it's considered roughly symmetric. We don't really have a set point. To make those decisions, sometimes we need more data than just the mean and the median. Okay, but for this example, they are only 0.4 away, so they're pretty close together. So when it is approximately equal, then our graph is bell-shaped. Okay. So based on your part B, is the standard deviation a good measure? The answer is yes, because the data is bell-shaped. Okay. So the only time you're going to use standard deviation to describe the dispersion is when the data is bell-shaped. That's one of the key points for today. All right, let's quickly take a look at this graph. So it's asking you which graph has a larger standard deviation. Remember that the larger the standard deviation, the more the data is spread out. So if we look at our example, this data is between 6 and 10 versus this data is between about 1 and 10. So which one has data that's more spread out? The answer would be B. Okay. If we look at example B, for the first one, it's from 2 to 12, and this one is 0 to 8. So which one is more spread out? The answer would be A. Go ahead and try C on your own. And you should get the answer to be A, because this is from 1 to 12, and this is only 0 to 8. So two key things here. Standard deviation is used to describe the dispersion when the data is bell-shaped, the distribution is bell-shaped. And then the larger the standard deviation, the more spread out the data is. All right, next thing we're going to talk about is the empirical rule and normal distribution. So in practice, we often see data that is bell-shaped, which we call normal distribution. Or what's another word? Okay. The other word would be symmetric. Okay. Normal and symmetric go hand in hand. Okay. So when data is symmetric or normal, same thing, we use the following properties of the distribution to answer several types of questions. Okay. So the diagram below is considered a bell-shaped curve. Okay. This is, remember that standard deviation is the most popular way to describe data. Okay. In college, you might have professors that say, oh, our test created a normal distribution. What they're talking about is this bell-shaped curve. Okay. And this, when you have a bell-shaped curve, it's considered a valid test. Okay. I know that's kind of hard to believe because I know oftentimes we want A's and B's, but this is considered a valid test when you have a normal distribution. You also have professors in college that will sometimes base their curve off of the normal distribution. Okay. So what exactly is it? Well, from this innermost portion right here, 68% of the data is within one standard deviation. Okay. Where we get that 68% from is each one of these is broken up into 34%. Okay. So 68% of our data will fall within one standard deviation away from the mean when we have a bell-shaped curve. Okay. And let's go ahead and fill in the other percents. After that, we have 13.5% on each side. We then have 2.35%. And then finally, 0.15%. Notice that all of these percents would add up to 100%. And also notice that each half is 50% of the data. Okay. So then the second portion is 95% of the data will be within 2 standard deviations from the mean. Okay. And then our last bracket out here is 99.7% of the data will fall within 3 standard deviations from the mean. All right, let's go ahead and on the bottom of our bell-shaped curve, let's add in all the symbols for this. So remember that standard deviation is the average distance away from the mean. So this middle right here is considered the mean. And then 34% away on each side is the mean and 1 standard deviation away from it. So go to the right, we add 1 standard deviation. When we go to the left, we subtract 1 standard deviation. Then we have 2 standard deviations away. And then our last one is 3 standard deviations away. You guys need to know this diagram. You need to know the percents. Basically, I don't like saying memorize, but you do need to memorize the percents and how much data is within 1 standard deviation, 2 standard deviations, and 3 standard deviations away from the mean. All right, so we call this the empirical rule. Okay. And use the 68, 95, 99.7 to memorize it. So 68, 95, 99.7. Okay. So about 68% of the data is within 1 standard deviation of the mean. Okay. About 95% of the data is within 2 standard deviations of the mean. Okay. And then the last one, about 99.7% of the data is within 3 standard deviations of the mean. Once again, we can only use this rule if the data is bell-shaped, or in other words, normal or symmetric. Okay, so 68, 95, 99.7 is what you need to remember. All right, let's go on to the next, the empirical rule. So for these examples, it asks you to see if the empirical rule is appropriate to use General statements about the miles per gallon of each car. Okay, to save us on time, I'm going to go ahead and just give you guys the mean and the median so we can compare the data from there. So for the first one, you get the mean to be approximately 223.5. And you get the median to be 223. So since the mean and the median are approximately equal to each other, then we would consider that the data is bell-shaped. So yes, we could use the empirical rule because the distribution is bell-shaped. Okay. Remember, we get bell-shaped off of the mean being approximately equal to the median. Okay. For the second example, the mean is approximately 237.2 and the median is 230. In this example, the data is skewed right because the mean is greater than the median, so therefore we cannot use the empirical rule to make general statements about the data. So the only time we can use the empirical rule is when you have normal distribution, or in other words, bell-shaped. All right, so now we're going to go on to the bottom example. And it says the weights of 1,000 boxes of cornflakes filled by machine are normally distributed with an average of 14.5. Okay, and as soon as we have our average, we're going to put that in the middle down here on our diagram. And then it says with a standard deviation of 0.5 ounce. So what that means is in either direction, you're going to go 0.5 away from the average. So we're going to add 0.5 to the right and subtract 0.5 from the left. Okay. So once again, you take the mean, you put it in the middle. Okay, that's why we can use standard deviation, because it's a bell-shaped curve. And then since the standard deviation is 0.5, then you go 0.5 in either direction. So this is 1 standard deviation, 2 standard deviation, 3 standard deviations away from the mean. Okay. So let's fill in our percents to help us out. So this is 34%. Then we have 13.5%, 2.35%, and 0.15%. Okay. And then remember that the data, the 68, 95, 95.7 rule, 99.7 rule. So we have 68% of the data is 1 standard deviation away. 95% of the data is 2 standard deviations away. Then 99.7 is 3 standard deviations away. Okay, so let's go ahead and fill out these questions. So it says, what percent of boxes is between 14 and 15 ounces? So we look at our normal distribution, and between 14 and 15 is right here. So that would be 68% of the data. That's 1 standard deviation in both directions away from the mean. Okay. Then it wants to know what percentage of the boxes between 13 and 14.5 ounces. So now we want to go over here, 13 to 14.5. Okay, so we're going to take these 3% and add them up. We do not include the 0.15 because that's on the opposite side of 13. So we take from 13 to 14.5 and add up all the percents, and you should get 49.85%. Okay. Then we have 13.5 to 15 ounces. So we're going to look at 13.5 to 15 ounces. And we're going to add up all those percents. Okay. Remember from here to here is 68%, and then here is 13.5%. Add those two together, and you have 81.5%. Okay, so you're just adding up the percents for the data that it's asking. The other type of problem you're going to see is how many boxes are between 13 and 14.5 ounces. So it's not asking for percent, it's asking for how many boxes. So we go back to 13.5 to 15 ounces. Or sorry, 13 to 14.5. So I want this portion right here. Okay, that is 0.4985%. I'm going to multiply it by how many boxes I have, which is 1,000. That comes out to be approximately 498.5 boxes. If you round up to 499, that's fine. Just don't forget your units. Okay. So for these types of problems, you find the percents that it wants for those standard deviations and then multiply by the number of boxes that you have. So if we look at 14.5 to 15 ounces, so 14.5 to 15 ounces is 34% of the data. So 0.34 times 1,000 equals approximately 340 boxes. And actually this example, it is 340 boxes. You don't need the approximation. Okay. All right, so we're going to go ahead and call it a day from there. Your homework for tonight is worksheet 5, and we will be reviewing on Monday when we have a quiz on Tuesday. If you guys have any questions, email me over the weekend. I'll be checking my email. I hope you all have a wonderful weekend, and tomorrow make sure to look for the Operation North Pole through Palatine. Look for our train. Have a great weekend, everyone. Bye-bye.